meeting? Okay, can you confirm na makakita na mo sa akong shared screen? Okay, good. We can start. You may record the discussion for the benefit of those wala pa dire, and then you can also make this as a future reference. So last time atong discussion was it's about calculating the seismic forces of our sample building, a 3-story building, and then we calculated the base shear, the period of the building, and then the distribution of the forces using equivalent lateral force method according to our NSCP code. So today I would like to discuss some principles, basic principles in designing special moment frames, or what we call SMF, or locally ang common ang ginagamit is SMRF, or special moment resisting frame. Now, last time, diba, I mentioned that majority of the Philippines is located within Zone 4 region, which is a high seismic region, including Cebu City. Ang dili included sa seismic Zone 4 is Palawan and the western part of Mindanao, like I think Zamboanga and mga islands that is sa west, Basilan, Holo-Solo, mga islands. And the rest of the Philippines is under seismic zone 4, meaning the earthquake or seismic activity is very active and usog ang mga earthquake na potential na mo happen in that zone. Now, according to the code, if the building is situated in zone 4, dapat ang atong gamiton na lateral framing system should be categorized as a special moment frame. So meaning, kaning special, there are certain detailings that we have to implement and we have to apply to our system, to our building frame system, so that it will behave in a ductile manner during an earthquake. It will not behave in a collapse mechanism. So mura siya ductile in a way na it has the capacity to absorb the energy of the earthquake. And actually the intent of this is for the occupants of the building to go outside of the building before ang building totally damaged, or of course there will be some buildings na collapse because the code does not say if you design a building according to the code it will not collapse, because there is a certain limit, probability. In fact, the code assumption is 10%. 10% of the buildings that you design according to the code might collapse. So, kaning special moment frames, you can reference or look at the ACI 318M, M for metric, because there is an English version of ACI, English units na version, the inches and the feet. So ang metric version is labeled as M. 2014 ang reference of our current NSCP code, 2015. So you can look at both references. They will have the same provisions. Now, one of the basic concept when we are going to design for special moment frames is kaning gitawag na to frame proportioning. So there are limitations to the dimensions of the frame. Starting with the span, no? The span of our beam. Kaning beam is part of the SMF or lateral framing system. So if it's an SMF, then the span should be greater than or equal to 4 times the depth of the beam. If you look at the section here, the depth is our D in our beam design. No? It's the distance from the center of our reinforcement to the outermost compressive fiber or section of our concrete beam. So meaning we cannot design a beam as an SMF na very short ang span because you have to satisfy this limit. Another limitation is the width of the beam. So ang limitation niya is the width of the beam, kaning BW, should not be less than, or it should be greater than or equal than 30% of the height of the beam, where the height is the total depth of the beam. And then the total depth or the height of the beam is also limited by this kaninga dimension. So it should be less than or equal, meaning this one is the maximum. It should be less than or equal twice the height or the dimension of the column 1, HC1. Take note, ang HC1 is the dimension along the span of the beam. Kung imo tanawan nga section BB. And then another limitation. So by the way, ang BW, ang pinaka-minimum for BW is 10 inches, or in metric, that's 250 millimeters ang minimum. So you cannot specify a 200 mm width na beam that will be part of the special moment frame. But for gravity framing systems, if the beam is intermediate and it only carries gravity load, wala siya nag-carry of seismic force, then you can always use a lesser width, no? Napabayan. Let's look at another limitation. So we have here the ratio of the column section, HC1 over HC2, the ratio should be within this range. It should be greater than 0.4, but it should be less than 2.5. So dili pwede ang column medyo ang aspect ratio niya is kanang rectangular na gid kaayo, because it will now behave as a wall rather than a column. No? So that's why the code sets a limit for the aspect ratio. Take note, ang minimum dimension of a column, both HC1 and HC2, should be greater than or equal 12 inches or 300 millimeters, equivalent niya. When you're going to practice someday, especially if maka-encounter mo mga architects na medyo particular sa ilahang design, or you might encounter some architects with minimalist design concept, they might try to insist on using sections, especially sa columns, na less than 300, because most of the time gusto nila nga ang kanang column is no flush sa wall. So if the wall is 6 inches, that's 150 dugangan nimo og cluster 1 inch both sides, so more or less nasa mga 200. So gusto nila i-flush ang column sa wall, so mahimo na lang 200 imong column. So strictly speaking, I mean, if you're going to base it in the code, dapat dili ka mo below sa 300 if that column is part of your lateral framing system. Also the beam, so common po ni nga the architects might, insist on having thinner na section sa beam for their, minimalist or architectural minimal design. So again, you have to be mindful about these limitations according to the code. Another principle to consider for the design of SMF is kaning tulo ka principles. One is the principle of designing a strong column and weak beam configuration. So dapat ang strength sa atong column mas lig-on siya compared to the beam. Now, because when the column will fail, it will result into a vertical collapse of our building. Whereas kung ang beam ang mo fail, usually ang failure sa beam is mo sag or mo deflect or na shear failure, but it will not result into sudden collapse sa building. Diba? And we want our building to behave in such a manner na there is no sudden collapse na mechanism, because we don't want I mean our objective is basically to protect the lives of our occupants sa building. So kung ang imong mechanism sa failure is kanang column mechanism, di pa kagawas ang mga occupants sa building during earthquake, mo collapse na imong building. So manang kinahanglan ta mong adapt ang new principle. Second is we have to detail the beams and the columns for ductile na behavior. As we know, concrete is brittle, diba? Without the reinforcement, brittle man ang columns. That is why we need the reinforcement to make it more ductile. We need the steel. Now, for SMF, napagi additional requirements when it comes to detailing the beams and the columns, so that when there is an earthquake, you can ensure a ductile behavior sa imong beams and columns or sa imong frames. And then third principle is to avoid non-ductile na failure. So looking at these diagrams, kaning first diagram, this is what we call the story mechanism or kaning collapse, sudden collapse ng iyang mechanism. As you look at the diagram, ang column is nag-una og fail. No? Kaning mga circle, these are what we call plastic hinges or diri ni una og yield ang imong building. If you look at the beams, ang buildings remains elastic. So wala siya ni yield. Because in this configuration, the beams are stronger than the columns. So nag-una ang columns to fail. And we don't want this to happen in our buildings. So we don't want to design a column na very slender and then ang beam nimo is very rigid and it will, it might behave like this. Ang gusto nato nga behavior sa beam, if we are going to design special moment frames, is either intermediate mechanism or a beam mechanism. So kaning beam mechanism, ang tanan beams of the entire height sa imong structure will yield, whereas the columns will not yield. Mo remain siya nga elastic, no? Wala siya yielding. Kaning intermediate, i-allow nato ang beams on the lower portion of the building to yield, and then at a certain height, mo allow ta nga ang column will yield, and then on the upper portion, the beams and the columns will remain elastic na. Gi-allow ni sa code kaning intermediate mechanism because kaning beam mechanism is I think this is impractical to achieve sa design because you might end up having a very large section sa columns, and it has economical na effect or affects imong structure. Your cost will increase significantly if kanigid imong i-follow. So that's why the code allows for this one. So pasabot ana, if you follow the prescription of the code, the prescriptive kanang mga sections, mga design parameters based on the code, ang imong moment frame will behave in this manner, kaning intermediate mechanism. Another concept is the detailing of ductile behavior. So kung tanawon ni mo dire, sa section AA, we have to detail the beam to make sure na walay shear failure sa imong beam. Common nga practice is to only use kaning outer nga stirrups or transverse reinforcement for the beam. But normally, kung the beam is kaning special moment frame, we might need additional na cross tie to add shear capacity sa atong beam. Take note, if you look at the hook, not the hook, but the hook. Look at the hook. Kung seismic galing nga detailing, the hook should look like this. It should be 135 degrees. Now, common sa construction, especially sa mga dili kayo experience ng mga contractor, they normally put a 90-degree nga hook sa ties kay masayon man siya i-install sa site, especially if your rebars are congested na. Example na kay napulo ka rebar dire. It will be very difficult to install the ties kung naka 135 ang imong hook. Now, take note, kanang 90-degree nga hook is not pre-qualified, or it's not kanang it will not ensure ductility of your beam na behavior kay ang tendency ng 90 degrees is when there is kanang cyclic na stresses sa imong beams, cyclic because kung earthquake magbali-bali man itong frame, it will move to the right, to the left, right, left. So there is a kanang cyclic na stresses dire. So ang tendency ng 90-degree hook is mukalas. No, dali na siya mukalas. So it will no longer hold the concrete in place. So manang sa seismic detailing, we need to ensure na our hook are 135. But for the cross tie, kaning cross tie, i-allow ka sa code na only one end is 135 and the other end is pwede na 90 degrees according to the code. For the column, look at this section. So common pod na practice especially for kanang mga inato lang na construction, they only put lateral ties sa exterior. But kung imong columns has, for example, there are pinaka-bars, 4, 8, 12 ka-bars. Kung imong butangan og ang imong ties is only on the outer side, there is a tendency that this section will fail easily due to shear. No? Okay. Ang kaning inner bars na to, dili man siya ma-engage with your outer ties. So ang tendency, this inner bars will easily buckle. And in the next slide, I'll show you a picture kung unsa na siya nga failure because of kanang poor na detailing of the column. So dapat when we design for columns, we should make sure na we have this type of detailing to ensure that this will behave in a ductile manner. So this is a picture that I mentioned earlier. So if you look at here, due to seismic, no, and then poor nga detailing sa kaning ties, the vertical bars of the column is ni buckle and then ang ibang concrete ni burst because of the shear. So if you don't apply proper detailing, so this might happen sa imong building. Next is analysis procedure. Last time we discussed about I showed you a kanang 3D model using RAM, and the analysis procedure I used in that model is the equivalent force method. But there are more advanced na method. We have the modal response spectrum analysis and we have the time history analysis. But normally kaning duha, the MRSA and the time history analysis are applicable for mga dagko nga buildings, mid-rise, high-rise, and then kanang mga complicated na buildings, highly irregular buildings. Irregular, like kung imong shape sa plan is naka-L or naka-U or irregular nga mga shape, then the equivalent lateral force method might not be able to capture the behavior, the exact behavior of the structure. That's why you need to implement this. But for our sample building regular, it's just a rectangular nga shape, wala man siya irregularity, then equivalent lateral force or ELF is sufficient for that example na building. Another parameter that you have to consider is the stiffness, modeling the stiffness of the beam and the columns. Now, if you're going to use a software like STAAD or Katongorama, kung ipakita last time, before you analyze the frame due to seismic load, you have to specify kaning stiffness factor or stiffness modifier to capture the crack behavior of the beam. So of course, ang concrete it will always crack no matter how you design it. So dapat ang imong i-model is not the entire section. So bali-bali imong i-simulate na the concrete will crack. So you cannot say the whole section of the beam is effective. No, only a certain portion of the beam and the columns will be effective. That's why you need to implement this stiffness factors. So the beam, according to ACI and NSCP, it ranges between 0.35 to 0.5. And for the columns, it ranges between 0.5 and 0.7. For conservative and for practicality, typically we just use, ang common nga practice is to use the lower bound. No? Para conservative lang kamay. 0.35 and 0.5. But if you want to have an exact yun nga analysis, or if you want to get the exact na stiffness factor, then you can evaluate the the section according to ASCE 41. But for simple na structures, I don't recommend using this one because it will just, it's cumbersome and it will not have a significant effect sa imong structure. Because this one, ang iyang effect lang, by the way, is na siya direct nga effect sa drift or lateral displacement sa imong structure. Because obviously, kung gamito nimo nga factor is 1, meaning the entire section is effective, so medyo stiff or rigid ang imong structure, so the displacement will be smaller. But if you model cracked section using 0.35 and 0.5, so murag i-reduce nimo ang section of the beam and the column by, kung 0.35, that's 65% imong reduction. For the column, that's 50%. So you'll expect a higher magnitude of lateral displacement po. So kung simple lang imong building, 2-story, 3 stories, wala kay siya significant effect sa building. So this one is only recommended kaning mas accurate na computation of the stiffness factors for taller buildings and highly irregular na mga buildings. Another concept is what we call the beam column modeling. Common modeling is to assume that the columns and the beams are rigid at the center of the node. But a more advanced analysis is to model a partially rigid model such joint. So for simple structures, you don't need to apply this one, but for more complicated structures, you can implement this one to get a more accurate results. Another concept is the modeling of the foundation. So there are many ways to model the foundation. Pinaka-simple, pinaka-common na modeling assumption is the pinned na base. So meaning ang column nimo imo lang ipin. This will give you a more economical na footings because your footings will have no moments, only axial load, axial and shear. So basically, imong footing will be smaller. Now, another common assumption is the fixed base. Now, ang kaning pin base, it will have smaller footings, but your lateral displacement will be more compared to fixed. So ang fixed, ang imong footings will be larger because of the bending moment, pero ang imong lateral displacement ma-minimize nimo. So again, for shorter 2-story, 3-story building, kaning pinned assumption is it's the most practical assumption rather than using a fixed base. Pero kung medyo taas-taas na structure, and then you will have a difficulty of satisfying the drift limits sa building, then I would suggest na pwede nimo gamitan ng fixed base. Or it could be a combination of pinned, kaning letter second na diagram, ipin nimo imong structure, then you put a grade beam. Pasabot na ang moment sa base sa column will not go to the footing but will go to the beams, to the grade beams. Ang imong footing will only have axial force similar to the pinned na base. So this one, kaning modeling, more advanced, and it will, it will minimize both the size of the footing, and then it will also minimize the lateral drift of the building. Kaya medyo naama kay stiffness sa imong base. But ang iyahang disadvantage is you will have additional grade beams, which is additional cost po. It's additional cost to the building kay magputang man ka og concrete and then rebar, and then ang pag-excavate sa grade beam. So na siya additional na cost. So in normal practice, sa akong practice, I usually use this one and then grade beam, but I also do sensitivity nga analysis. So I'll try to model kani, and then I'll try to check kung thin lang siya, kung sa niyang effect sa economy sa building. If the difference is dili kayo dako, then I might use this one. Pero kung ang difference gani is dako kayo, then I have to use a more simplified or a more kuan nga model kaning more economical ang iyang result. A more accurate na modeling is what we call kaning na ice cream. More accurate but more difficult to do. Kay this is an iterative na process, no, kanang balik-balik, because you have to do initial assumptions in footing, i-analyze nimo, and then you get the spring values, and then kung dili mo satisfy, then you increase na to the footing size. So na ay iteration, it will take time, more time compared to the simplified na model sa pin with grade beam or fixed modeling. So this is only recommended for certain conditions. Kung ang imuhang soil is sensitive to settlement, then it's recommended to use this type of modeling. And makapture man nimo ang settlement sa soil through the springs. Let's go now to the basic requirements for the design of beam reinforcement. So I think in your previous na lecture in reinforced concrete, previous SEM, gitudloan man mo how to compute or how to design a beam, no, na kay bending moment, and you design for 3 bars. You have singly reinforced na beam, or you can also design a doubly reinforced na beam. And then you were also taught how to design for the transverse reinforcements for the shear. Kaning akong gipakita na slide, this is in addition to what you learned before, no? Kay kani siyang requirements is for seismic. This is for special moment frame. So this is on top of the basic requirements or standard na requirements na you learned sa una ninyo na lecture. So in here, if the beam is part of the lateral frame, SMF, so if you have a negative reinforcement here, nag-design, then ang bottom nimo, a bar directly below this bar sa support, there is a certain limit. So dapat ang reinforcement dire should be greater than or equal to 50% of the top bars. So kung ang imong required top bars is say 8 bars, 8 ka 16 millimeter bars, and then sa bottom, pag design mo duha ray requirement, but you still need to increase it to 4 because of this additional requirement due to seismic. So kung 8 dire, ang imong minimum reinforcement sa bottom bar at the support should be 4. Kaya mo may giset na limit sa code. Although sa computation nimo pag designing mo is only 2, but you are still required to increase it to 4. So same story here. And then ang diameter there is a rebar. There is also a limit, no? The diameter of the rebar should be less than or equal to HC over 20, where the HC is the column dimension. And then the splicing of the top bars, it should be twice the height of the beam away from the face of the column. Okay. This is our hinge zone sa beam. So dapat wala kay splicing diri dapita near the support with this given limit. Dapat ang imong splicing is mo lapas sa 2 times the height of the beam. Another requirement is at any section of the beam, the positive and the negative reinforcement should be greater than or equal to the maximum rebar, MN pasabot na capacity of the beam, so basically ang rebar, at either joint divided by 4. And then another requirement kanin sa taas, the positive and the negative reinforcement should be less than or equal to this magnitude, or this is the area of steel, no? So it should be 2.5%. The minimum is the it's not minimum, but it's maximum is 2.5%. The area sa steel. Minimum is given as this one. So let's go to the shear requirement spot for SMF, for special moment frames. So sa shear, you have to follow this limitations according to ACI and NSCP code. So your first bar, first lateral tie is normally placed at 2 inches or 50 millimeters away from the face of your column. And then the spacing of the hooks or the transverse reinforcement within the hinge zone, kaninga zone, it should be less than or equal to 150 millimeters or 6 times the bar diameter or 25% of the depth or D/4. So dapat isatisfy nimo ni nga spacing on top of the spacing nga gi-require pag-compute nimo sa capacity. At this zone, beyond the hinge na zone, the spacing of your transverse ties or transverse reinforcement should be less than or equal to 50% of the depth. And then sa splicing zone, these are the requirements. So naakay D/4, ang spacing should be less than or equal to D/4 or 4 inches. Ang ihang equivalent na SI is 100 millimeters. So this is how you detail the hook. Take note, there are 2 terms gigamit sa transverse ties for SMF. We have what we call the hooks and we have what we call the stirrups. Hooks, according to the code, should be detailed, similar to this figure, no? So for this one, the outer detail is the outer transverse reinforcement is detail A, could be this one. So dapat na seismic hook ang boat. But commonly sa local, sa Pilipinas, ang atong gamiton is katong closed hook or closed ties, but with seismic hook yapon on both ends. So kani sa US mo nga practice, ang ila is mas I think mas sayo ni siya i-install. Kaya pwede naman nimo ning i-install balagi mo lang binaton ang duha ka leg and then i-insert nimo sa longitudinal reinforcement compared sa katong closed siyang na hook. And then ang atong detail B, so in this configuration na kay detail A, which is this one, and then you have detail B on top para ma-close ang inyong hook. Ang detail B again is a cross tie with 135-degree hook sa one end and a 90-degree hook sa other end. Take note of the dimension of the hook. So ang imong dimension sa hook should be, kung 90 degrees, it should be 6 times the bar diameter. So if this is 10 inches, 10 millimeters ang imong bar, then the minimum extension should be 60 mm. So similar to the 135 hook, it's it's the minimum between 6 diameter bar or 75 millimeters. So another limitation is the maximum spacing between bars explained by legs or hooks. So kung imong beam is too wide, for example, 500 millimeters, then you are required to add intermediate na cross tie. Because according to the code, the minimum spacing between longitudinal bars na walay hook or walay cross tie is 14 inches or 360 millimeters. So kung mulapas na gani imuhang bar na walay tie o 360, say 500 ang imuhang width, so paano mo covering more or less nasa mga 400, so you are obliged to add additional na hook or additional na cross tie. Could be 1 or could be 2, depende sa requirement. For the column, this is a diagram or a figure showing the limits for the spacing of the ties for a column. So we have this similar to the beam, napod tayo duha ka zone. So we have the hinge na zone, kaning LO and LO sa bottom, and then we have the splice zone. So within this zone, kaning LO, by the way, the dimension of LO is given as this one. It should be greater than or equal to the 4 values here. HC1, HC2, LU over 6. LU is the height of the column, the clear height of the column. So meaning from the bottom of the beam sa top and from top of the beam sa bottom sa column. It should be LU over 6 and then 18 inches or 460 millimeters. And then we have spacing of the ties. S1 na spacing, S1 is for the hinge na zone or LO na zone. S1 na spacing should satisfy these requirements. So it should be minimum HC1 over 4 or HC2 over 4. Also satisfy the 6 diameter bar. Or SO, where SO is given as this one. Money ang equation for the SO. Or as required for shear. So kung nakaka-requirement here, pila spacing, dapat isatisfy gyapon nimo ang kaning tulo ka minimums. So for S2, ang S2 is for the ties away from the hinge. These are the requirements. So 6 times diameter or 6 inches or 150, or as required for the shear load. And then for the splicing zone, although the shear, di ba kung i-plot nimo ang shear sa column, maximum sa top, and then mo zero siya sa mid-span, approximately sa mid-height, and then maximum na po siya sa bottom. Diba ang inuhang stress diagram for shear sa column. But if there is a splicing sa mid-height, although walay required or minimum ang required na size according to the stresses dire, but because of the splicing, you are required to have the S1 na spacing. And then this is the section for the column na reinforcement or ties. So as you can see here, natay limits. Again, ang atoang hook should be seismic hook or 135 degrees. So we have an outer ties, and then we have inner ties that should satisfy either the shear, the required shear for the column, and the minimum dimensions between two longitudinal bars or vertical bars na unsupported sa ato ang ties. So kaning XI. According sa code, the XI from center line to center line of supported bars shall not exceed 360. So similar sa beam, 360 ang iyang limit. Sa kanilain. Okay. So that's it for the special provisions for special moment frame. Ang references akong gikandak na lecture is kaning ACIP 1814, NSCP 2015, and then the technical brief number 1 for seismic design of RC SMF. I'm going to send the third reference kay wala makoy copy sa NSCP 2015. I only have a hard copy. And then ACI, wala sa makoy copy. So I'm going to send this sa chat. I don't know if possible is send ang PDF sa chat. I think really possible. So I'll have ano na lang, Jancy, to upload this. By the way, here's a sample spreadsheet for a design of beam. Pero kani siya nga spreadsheet is only applicable for gravity loaded nga beam. Na wala pa din incorporate ang requirement for seismic detailing. It's only for gravity. So you can make this as a reference. Here's another spreadsheet for the design of columns. This is only for gravity. There is no provisions here for seismic. So you can make this as a reference and then you add na lang additional nga provisions or additional nga calculations for the minimum requirements of the code, especially sa lateral ties. Okay, do you have any questions?
We forgot you. I'll save you someday. I'll save you someday. And you will save us.
So if wala na, then I think that's it for my presentation. And
Sir, there's a question in the chat.
ay, okay,
Sir, make me ana. That's the question.
Jans? Unsa
Hello.
Nato is spreadsheet sample.
Good noon. So, your requirement for the next project is to design the girder and then the columns and the footings. So you will send that to me. The latest will be on December 18, which is the end of the classes. So I will publish the sample spreadsheet and then upload it in the announcements. The files will be uploaded in the Canvas, and then for your reference. Then after that, so that you can make your own spreadsheet for the design of the girders, the columns, and the footings. Nag-discuss pa ito? Wala na?
Magkakaroon ko spreadsheet na rin. I'll give them a
Footings,
spreadsheet.
okay. So all of those will be uploaded in the Canvas for your reference. Okay, so the latest again will be on December 18. Still, I will announce it in the Canvas because that will be the end of class, the final exam week or the end of classes na. So I can make your grades during that time sad. Okay, so kung madelay mo ana, then if ever makasubmit ako grade, murag, I don't know if INC, I will just input INC or incomplete. No na, kamo na i-process ana na sa change of grades. Okay, pero definitely ang ako lang tagaan og grades kadto lang makasubmit on time. Okay, so yes. Almost 2 weeks pa man.
Yes.
Ang gravity loads kay beams naman na ang girder kinano siya seismic. Katong nanamay ni submit og seismic the last time. So if naamoy seismic loads, i-input na lang na sa spreadsheet sa gravity loads. Okay?
Hello, Miss. Pwede mag-ask a question, Miss.
Yes.
Regarding sa katong results sa mong seismic analysis, Miss, bakay, how do we apply it, Miss, in the design of girder since seismic load naman
Ang
siya?
moment loads. Oh, did you arrive with the moment loads?
Ang katong distributed shear, Miss, distributed story shear so far.
Sabi Hello? Have you seen the uploaded katong reference na gi-upload ako today? Na-added to ang share, actual load ug moment load, derived from seismic analysis. Na from there, mo to inyong input para girder design and column.
So, bale, separate case na po siya, miss. Bale, tulo na ka-case ang among i-consider.
Sa girder design, kay naman may moment load. Naman may moment load kasi sa seismic.
Okay, miss.
Actual ug share. So, gikan dito sa seismic. Okay. Anyway, i-upload lang ako itong sa girder. So, dito ang mga inputs inyong na required gikan sa seismic. Okay. So, do you have questions? More questions? If you will contact me lang sa katong email o pwede rin sa mong chat sa Canvas kaya opening 8 man next time. So, if there are no other questions, so I think that's it for today. So you can start making the spreadsheet and then you submit it siguro mga next December 18 or siguro I can still go on until 20 December 20 lang. So I can still have time pa for almost 2 weeks. Okay.
Miss, can I ask, miss, one last question na lang?
Yes.
Sa katong seismic analysis, miss.
Oo.
Ang total story height bitaw, ang HN bitaw, miss, kay unsa atong base point ano, miss, ang katong below ground level or ang katong ground level?
Below ground or
Or ang katong ground level, which is katong 0 na to.
ang frame jud nimo so katong bilog ang kanang kutob jud sa height sa column. Hello, sa top of footing jud siya. Kay mo may imong frame. Total column height.
Okay, miss.
Nasud sa obis.
Sige, miss, noted.
Okay. Okay, so you have more questions?
Miss,
so that's yes.
no, miss. There is no like, format for the outputs, miss, no? Kami nalay bahala og modify.
Oo, kamulay modify as long as on your own masabtan ninyo ang output. Matanaw naman ko sa inyong output sa design. So, kamulay ka ng user-friendly lang na way para sa spreadsheet. Importante masabtan ninyo. So, kamulay ko ang design. I do not require na sundugon dyan ninyo ang format sa katong spreadsheet na sample. For as long as mas complicated pala itong sample kay daghan mga i-hide ba na pictures. If you want, para mas friendly ang Excel, ipakita ni pwede mo i-hide pero at least kasabot ka sa to derive mga equation. Okay, so that's it for today. Siguro, if you have more questions, just reach out to me through this email lang ha. Kay I am always online man. So, let me know if naamo ko yung pangitana kay reply ra ko. Thank you. Sige.